Hi, my name is Teos. I'm the head of product for Nodes and Links. And in this video, I will explain to you how our AI works. So let's have a look. Sorry. First of all, what does our AI do? It can automatically generate risk profiles for all your activities and WPSs in your project for the QSRA analysis. So essentially, what does this mean? You want to do a QSRA analysis, you want to do a risk analysis. As a human, you use your expertise. You can ask people, you have experience, you know which activities are risky, you know a way to express this risk. You will gather your work colleagues in a room, you will do a risk workshop and decide together on some more difficult activities. AI cannot do any of that. But what the AI can do is ask the data, and it asks the data efficiently. So what does it do? It looks at similar finished activities, and based on that, it makes a prediction. It's that simple. Under the hood, there's a lot of intricacies and complexities, but the principle is that simple. In fact, let's give you an example. Let's say that you have to do electrical works and you have to place a roof in the house. It will look at all the times you had to do electrical works in the past and you did it, and you had to place a roof in the house and you did it. And it will say, oh, you know what, last 2 times you did electrical works, there was a lot of delays, major delays. So I think if you try to do electrical works now, it's going to be high risk. Or last 2 times you placed a roof in your house, everything went smoothly. So I think placing a roof in the house is low risk. Essentially, that's what it does. You want to do something, I'm going to look at all the times you did it in the past, and based on that, I will make a prediction. So let's get into a bit more detail about how this happens. So I told you the AI creates a risk profile for every activity, right? What does that mean? You need 2 things to create a risk profile: the distribution and the distribution parameters. Might now want to say, hang on a minute. You mean duration, uncertainty, and distribution? Kind of. You see, what we really call duration uncertainty, in fact, is the parameters for the distribution. Let me explain to you what I mean. Let's have an example. For example, you have the dice. Throwing a dice has 6 outcomes from 1 to 6, and they are all equally probable. We call that a uniform distribution. You can see everything has the same probability. If you want to express dice roll in risk analysis, you will set the distribution to uniform, and the parameters of that distribution, you need 2 values, the minimum and the maximum. So minimum will be 1 and maximum will be 6. See, what you have in mind as duration uncertainty, in reality, it's the parameters of the distribution. And this is how you model one dice throw in risk analysis, by the way. Let's do 2 dice now. When you throw 2 dice, results are from 2 to 12. Okay, great. Notice though that not all results are equally probable. I mean, in order to get a 2, you need to get just a pair of 1s. In order to get 12, there's only 1 outcome, pair of 6s. But there's a lot of combinations that can lead to a 6, 7, or 8, with 7 being the most frequent. Given that the shape of the probabilities, the distribution looks like a triangle, that's why we call it a triangle distribution. And in order to model that in risk, it's a triangle distribution with a minimum value of 2, most probable value of 7, and max value of 12. Again, it's not that the duration uncertainty is mean 2 to 7 to 12 and the distribution is triangle. The distribution is a triangle, and its parameters is what we call duration uncertainty. By the way, this is why 7 is the most probable one. That's why when you're playing craps in a casino, 7 wins. So extra information for you. So, as I said, when the AI creates a risk profile, it decides on the distribution and distribution parameters. Okay, fair enough. You will tell me what about risk events? AI doesn't really need risk events. Risk events is in its prediction, risk events are included since it looks at performance of past activities and this performance is already affected by the risk events. By looking at the past performance, risk events are taken into account. If you think about it, risk events are a way for us to express known risk. Well, with duration, certain distribution parameters, as we call them, being the unknown risk. If you're looking at previous performance, risk events has already cast their vote and they are already being taken into account. In fact, you select a triangle distribution, for example, normal as a human, you add the risk events, and under the hood, something like this happens. The risk events affect the distribution. AI directly gets to that point. So we're good. So let me reiterate. The AI looks at past performance. It's very good and efficient in doing that. The AI decides a risk profile for its activity. That profile is a distribution type and its parameters. Humans do that by asking, using their expertise. The AI asks their data. Oh, and by the way, what we look when we say similar activities, we look at the name and activities at the same WBSs, and then we slowly climb it. So, sorry to reiterate, AI asks data, humans use their expertise. The AI, and the only reason why the AI does use data, doesn't have the years of experience that you have. So let's have a look at an example just to understand a little bit better how this works. Let's say that you want to do the place roof in the house, if you remember from this example that we had here. So the first thing that we're doing is we want to find the distribution. What the AI does is literally takes all the similar activities and it gets the delays. As you can see here, the gray lines here are the delays of the similarity. So basically, this is the duration increase in delays, and that's probability. So a lot of them had 25% increase. Some of them had less than 25% increase. There were some that had a lot of increase. It literally takes similar activities, plots them, and then on top of that, it plots the distribution. It says, okay, this is what happened in the past. That line that follows my data, that's my distribution. In fact, does it do that every single time? No, we found some through fancy math. You can find them here. That most of the times, the distribution that actually follows the risk is what we call the logarithm. Does this thinking? What does that mean? It means that most of the activities, most of the times, you don't have a lot of duration increase, but there are some edge cases that there is a lot of everything goes very wrong. Small chance, but huge impact. And you can see that even when you're doing risk workshops, you can see that, there's P50, 2 months, P60, 3 months, P70, 1 year, P80, 3 years. It's in order to get up to P80, suddenly it explodes. So, okay, we have the distributions. How do you do the parameters? We have, we basically have a network and it inputs the activity name and the plant duration. We turn the activity name in a words vector in order to get the similarity. We have a neural network and we have trained it that it basically outputs the distribution parameters for that activity. And that's how you get to this. So basically now you can run your QSRA analysis. You can use both human input and non-Genix AI in order to run your QSRA analysis. So I hope that helps you understand a bit better how we come up with the distributions and the input for How does the AI does its thing? But now let me talk to you a little bit about practical application. That was a theory. The AI is not omnipotent, okay? It's a data-driven prediction that can happen at the click of a button. It's not here to replace the risk manager. The AI cannot beat the expertise of a risk manager. But in practical terms, a schedule has around 15 to 30,000 of activities. I mean, you need to do all that for every single activity 30,000 times. No one has the time to do that. No one realistically can make a risk workshop for every single activity. Okay. The best way to use the AI is to use the AI. Usually, most people, what they do is they're actually focusing on thousands of activities, and then they're actually, for the rest 29,000, they have some generic values. That's where your best use of AI is. Keep focusing on those thousands of activities, but for those 29,000, just use the AI. It's gonna be way better than a generic value. And not only that, but you can also have a data-driven second opinion about even the main activity that you want. So, and that's the thing, the AI outputs input for your QSRA, but you can see that if you don't like it, you don't have to use it. And you don't have to use it. It's not everything or nothing. You can just use it for whichever activities that you want. We've purposefully built it like that because it's not here to compete with human expertise, but to complement it. Okay? It's not here to argue with you and fight with you. It's here to give you a second data-driven opinion, or it's here to do the groundwork for the rest of the thousands of activities that you don't have the time. Realistically, you don't have the time to work with. That's it. Thank you very much. If you have any more questions, don't hesitate to contact us. Have a good day.